This video is on comparing linear functions. Given the function f of x in the table below and the function g of x that has an x-intercept of 3, 0 and a y-intercept of 0, 6. Question A says to make a sketch of the graph of each function on the coordinate plane to the right. So the first thing we want to know is f of x has this table. We need to know the slope and the y-intercept. Same thing with g of x. We have an x-intercept of 3, 0 and a y-intercept of 0, 6. So we need to find the slope-intercept form of g of x. They are two different functions, which is why they're called f of x and g of x. So looking at f of x first, we want to find the slope and the y-intercept. So I'm going to use blue to represent this. Slope is change in y over change in x. So I can look at two coordinates on here to find the change in y. So f of x represents y. So the change in y is from -3 to 0. I would be adding 3. My change in x is from 5 to 10. Since I'm using the same coordinate, that's adding 5. So my change in y over change in x would be a +3 over a +5, which does not simplify further. Our y-intercept would be when the x value is 0. So if I want to try and find the x value of 0, I can use my slope formula, my slope to find the pattern. I can use my slope to say that my change in x is +5, but if I want to go backwards, I would say that my change in x would be -5. 5 minus 5 would give me 0, which is where I need to get to. So if I use the change in 5 on my x, then I need to use my change in 3 on my y. Since I went +3 earlier, I'm going to go -3. So I would go from -3, -3 would give me -6. So in order to write my function for f of x, so this is again y equals, so f of x equals, our slope is 3/5, our coefficient is 3/5, so multiply by x. Our y-intercept is when x is 0, our constant is that -6, so it would be -6. My equation for f of x is 3 over 5x minus 6. For g of x, I need to find my change in y over change in x, but then using my two coordinates, I also have the y-intercept of 0, 6, so I already have my y-intercept of 0, 6. I only need to find my slope. So to find our slope, we would do change in y over change in x, change in y over change in x, which would be, so my change in y would be, I would have a 6 minus my other y would be 0. Divided by my change in x, so if I started with 6 first, I have to use my 0 on my x, minus my other x is 3. 6 minus 0 is 6. 0 minus 3 is -3. This simplifies to -2. This is my slope for g of x. My y-intercept for g of x was 0, 6, so I can write the equation of y for g of x equals, our slope is -2 times x, and in my y-intercept was 0, 6, so my constant is a +6. Now that I have them in slope-intercept form, we can graph them. I'll graph my f of x. 0, -6 is the first coordinate, so I'm going to count by 1s on my x and y axis. So 0, 1, 2, 3, 4, 5, 6. And our slope is change in y over change in x, so that's a +3. Change in y of +3. Change in x of +5. 2, 3, 4, 5. I'll try that again. 1, 2, 3, change in y. 1, 2, 3, 4, 5, change in x. And I'll go the other way as well. Since I did a change of positive and a change of positive, I'll do a change of -3, 1, 2, 3, and a change of -5, 1, 2, 3, 4, 5. Now that I have as many coordinates as I can graph, I will connect these with a line and put arrows on the end. I'll do the same thing with my g of x. My coordinate for my y-intercept is 0, 6. So 0, 1, 2, 3, 4, 5, 6. And my slope is -2. So again, that's -2 over 1. So I can see my change in y over change in x. Change in y is -2. My change in x is +1. So I went down 2 and then right 1. Change in y of -2, change in x of +1. I'm going to do as many coordinates as I can to make my line as accurate as I can. Change in y of 2, change in x of 1. Change in y of 2, change in y of -2, change in y of +1. I'll go the other way as well. Change in y of +2, change in x of negative 1. Many coordinates as we can. And then we'll connect those with a line and put arrows on the end. We have now sketched a graph of each. Which function has the greatest rate of change? The greatest rate of change, we want to look at the values. We have f of x has a rate of change of 3 over 5, or a negative 2. If we're looking at the greatest rate of change, we want to see which value has the absolute value or the steeper of the slope. So even though negative 2 has a negative, even though g of x has a negative slope, it still has a faster rate of change because it is going faster. So we would say that g of x has the negative 2 has the faster rate of change. So g of x has a greater rate of change because it goes faster. What is the distance between the y-intercepts? So our first y-intercept was at negative 6 for our f of x. And we want to go to that positive 6 for our y-intercept of g of x. We can also count from these coordinates. We can count up and down. So from negative 6 to positive 6, we want to go from negative 6 to 0 and then 0 to 6. So that is going to be 12 units away from each other. That's 12 units away from each other. And if we count from our y-intercept, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not negative 12 because distance is never negative. What is the distance between the x-intercepts? We need to find the x-intercepts. In order to find the x-intercepts, we would look at where do they cross the x-axis. And if we look at the graph, we can see the actual coordinates of which they cross the x-axis, which is nice. So our first x-intercept would be at 1, 2, 3, 0. So from 3 to, so this one's at 4, 5, 6, 7, 8, 9, 10. So that's from 3 to 10. Those are the two x-intercepts, so 3, 0 and 10, 0. That has the distance of 7 units. And we can count from them. On this next problem, we're given the function f of x equals 2x minus 9 and the function g of x that is graphed to the right. Which function has a largest rate of change? So rate of change goes from the slope. So our first one is f of x. F of x has a slope, m equals, the coefficient is 2. Our slope is 2. The function g of x, which is on the right, we can find the slope from one coordinate to another coordinate and find our change in y over change in x. So if I use this coordinate right here, because it's going through a nice clean corner, and this corner right here, we can find the slope. So it has a change in y of counting 1, 2, 3. So we have a change in y of 3. So if we do g of x, change in y is a positive 3 divided by, then we have a change in x of positive 2. So our slope of g of x is 3 over 2, which is 1/2. So 2 is larger than 1/2. That means that f of x has a greater rate of change. F of x has a greater rate of change. Just by looking at the two numbers for our slope. We have to understand what it's asking for. Rate of change is another saying for slope. So number 2 says, given the function 8x minus 5y equals 15, and the function described in the table below, what is the difference in the y-intercepts? So we need to find the y-intercepts, and then we need to find the distance between them, so the difference of them. So given the function, so the first function of 8x minus 5y equals 15, we need to take that function and solve for it. So I'm going to rewrite that problem. 8x minus 5y equals 15. We need to solve for y so that we can get it into slope-intercept form so we can find our y-intercept. We want to subtract the 8x from both sides. So we're going to have negative 5y is equal to a positive 15 minus an 8x, because again, 15 and 8x don't have a common variable. Then we're going to divide both sides, everything, by that, whatever's attached to that y. So we're going to divide by that negative 5 on everything. So we're going to have y equals negative 5 divided by negative 5 is a positive 1. 15 divided by negative 5 is a negative 3. Negative 8x divided by negative 5 is a positive 8x over 5. So we can write this in slope-intercept form of saying y equals, our coefficient comes first, mx, so 8/5 x, and then we have our constant of negative 3. So the y-intercept of this function is 0, negative 3. The y-intercept for this table we have to determine. So we need to find our slope, and then we use our rate of change to help us get our slope. So what we want to do is find our slope. So if I go from change in y over change in x, so from 5 to 8 and 4 to 8. This is what I'm going to use. I'm going to use these first two coordinates. The change in y is going to add 3, and the change in x is going to add 4. So the change in y over the change in x is a positive 3 over a positive 4. So I need to get to the x value of 0. I need to go backwards from 4. So in order to do that, if I go backwards using this format, if I want to get to 0, I want to subtract 4 from the x. Well, that's the same number as our denominator, so we're going to use the same slope, but we're going to go backwards instead. So if I have to subtract 4 from the x, which is all my x's, I'm going to have to use that same 3 on my y's, but instead of adding, we're going to subtract 3. So in order, we get from 4 to 0, so we're going to get from 5 to a positive 2, because 5 minus 3 gives us positive 2. That tells us that our y-intercept of this table is 0, positive 2. So the distance between them, or the difference, is how do we get from 2 to negative 3? We get from 2 to negative 3 by going down 5, or we can go from negative 3 to positive 2 by going up 5. So the difference, or the difference in the y-intercepts is 5 units. Because we're going from a positive 2 to a negative 3. That is 5 units away from each other. It's not negative 5 because distance is not negative.